All right, in our first lesson, we're going to review one of the most important concepts in all of math. We're going to talk about the slope of a line and some applications that go with that. The constant rate of change of any equation or anything that's happening, specifically constant velocity, constant acceleration. All right, so let's suppose that we have a little guy here and he's running along flat ground, going in a straight line, and he runs past this tree. Let's say that 3 seconds after somebody starts a stopwatch, the little guy's 40 feet past the tree, so he's 40 feet to the right of the tree, 3 seconds after somebody starts the stopwatch. Let's say that 5 seconds after somebody starts the stopwatch, this guy's 70 feet past the tree. Okay, so he's running along. We don't know where he started, but somebody starts a stopwatch at some time. 3 seconds after they started it, he's 40 feet to the right of this tree. 5 seconds after the stopwatch was started, he's 70 feet to the right of the tree. All right. He's always going the same speed, so he has a constant speed, and he's always going in the same direction. So his velocity is constant. It always stays the same. Okay. Our goal is going to be to figure out how fast he's going, or his velocity. Okay, let's make a graph of our information here. So on the horizontal axis, I'm going to put the time, which is measured in seconds. On the vertical axis, I'm going to put the distance past the tree, which is measured in feet. Okay, so at 3 seconds here, he is 40 feet past the tree, so 10, 20, 30, 40. Okay, so I'm going to plot that information. 5 seconds after the stopwatch was started, he is 50, 60, 70 feet past the tree. Okay. Now remember, his speed or his velocity is constant. So every second, he's going to travel the same distance. Every half second, he's going to travel the same distance. So if every second he goes the same distance, so 1 second he goes up a little bit, another second he goes up the same bit, if we plotted all those little points in between, we would have a straight line. So if his velocity is constant, or the rate of change of this line is constant, it's going to make a straight line when you graph it. Okay, so we want to find his velocity. So velocity is the change in position over the change in time. So velocity is equal to the change in position divided by the change in time. Okay, so velocity measures how far you went divided by how long it took you to go that distance. Okay, this little triangle is a delta. It's a Greek delta, and we usually use it to mean change in. So this says change in position over change in time. How fast you go divided by how long it took you to go that far. So for this problem, if I wanted to find the change in position, or how far this little guy went, I would subtract these two numbers. If he was 40 feet at this time and 70 feet at that time, then he traveled 30 feet. That's how far his position changed. So I'm going to do 70 minus 40, and that is feet. Very important that we keep our units in there. On the bottom, I want the change in time. I want to know how long it took him to travel that far. So I'm going to do 5 minus 3 seconds. Work that out. 70 minus 40 is 30 feet. 5 minus 3 is 2 seconds. If we simplify that, 30 divided by 2 is 15. And our units are feet per second. So it's very important to keep the units in there. Feet per second. Okay, so this little guy is traveling at a constant velocity of 15 feet per second. 15 feet every second. So at 3 seconds, he was 40 feet past the tree. At 4 seconds, he would have been 55. Then at 5 seconds, he would have been 70. We can also go back this way. At 2 seconds, he would have been at 25 feet. At 1 second, he would have been 10 feet. And at 0 seconds, when the stopwatch was started, he would have been 5 feet to the left of the tree. All right, so let's talk about the slope of a line. So we want to find the slope of a line that goes through these 2 points. So first, let's graph the 2 points. So I got the point 1, 4. That would be here. It's 1, 4. 1, that's 4. And I've got the point 3, negative 2. There's 3. Here's negative 2. So I have this point. And we want a line that goes through those 2 points. We want to find the slope of this line. Slope is a measure of steepness, like on the previous problem. We were measuring the steepness of that line. The definition of slope is the change in y over the change in x. So to figure that out, we would, just like in the previous problem, we would subtract the 2 y's, subtract the 2 x's, and that would give us how much our y changed divided by how much our x changed. So we're going to do y2 minus y1 or x2 minus x1. Okay, the little 2 and 1 are called subscripts. All this says is that the second y and the first y, or the second x and the first x, or we can say it's the y from point number 2 and the x from point number 2, the y from point number 1 and the x from point number 1. Okay, it doesn't matter which one we call point number 1 and point number 2. So let's just say that this is point number 2, and we'll make this point number 1. So if we do that, so if this is point number 2, point number 1, this would be y2, and this would be x2. This, which is 3, negative 2, this would be y1 and x1. Okay, so point number 1, the x and the y, point number 2, the x and the y. So all we have to do is fill in the blanks in the formula. y2 is 4 minus y1 is negative 2. And we got to be really careful. It's minus y1, so it's minus negative 2 over x2 is 1 and x1 is 3. So 4 minus negative 2 over 1 minus 3. Okay, if we work that out, 4 minus negative 2, that's 4 plus 2, which is 6. 1 minus 3 is negative 2. Simplify that and we get negative 3. Okay, so in this example, our slope was negative. Notice that the line slants downhill from left to right. In our previous example about the velocity, the slope was positive and the line was going uphill from left to right. So as you move from left to right, if your line goes up, then your slope is positive. If it goes down, then your slope is negative. Okay, graphically, let's think about the slope. So the slope is how much my y changes divided by how much my x changes. So if I think about the y and how much it changes, I can just look at this graph and count. It goes down 1, 2, 3, 4, 5, 6. So we go down 6 and we go right 1, 2. So right 2. Now I said go down 6 and right 2. So if you went down 6, this should be a negative 6. And if you go right 2, that should be a positive 2. But notice these are the same. 6 divided by negative 2 is negative 3. Negative 6 divided by positive 2 is also negative 3. So it doesn't matter whether your negative is on the bottom or on the top, you'll still get the same answer. All right, so here's a second example. Let's find the slope of a line that goes through these 2 points. So I've graphed the 2 points over here with a line that goes through them. Before you even start, think about what the slope should be. Is the slope going to be negative or will it be positive? Well, if I'm going uphill from left to right, my slope should be positive. So make sure we get a positive answer once we're finished. All right, so the slope is the change in y over the change in x. Let's look at this one graphically first. So if I start here, in order to get from this dot to this dot, I need to go up 2, and I need to go over to the right 1, 2, 3, 4, 5, 6, 7. So I know my slope should be up 2, change in y is 2, so up 2, right 7. So my slope should be 2 7ths, just by looking at the graph. Let's work it out algebraically and make sure we actually get 2 7ths. So let's say this is point number 2 and this is point number 1. So this would be x2, y2. This would be x1, y1. So I just fill in the blanks, y2 minus y1. So I'll have negative 1 minus negative 3. Be really careful with these 2 negative signs. It's negative 1 minus negative 3. And it's 2 minus negative 5. Negative 1 minus negative 3, that's negative 1 plus 3, which would be 2. 2 minus negative 5, that's 2 plus 5, which would be 7. And our algebraic answer agrees with what we saw graphically. All right, let's look at an interesting example, a very important one. Before we start working this out and trying to find the slope, let's think about it graphically. So as I move from left to right, is this line going uphill or is it going downhill? Neither, right? It's not going uphill, nor is it going downhill. So let's see if we can figure out what the slope of this sort of line is. All right, so the slope is defined to be the change in y over the change in x. We know to get the change in y, we're going to do y2 minus y1. To get the change in x, we're going to do x2 minus x1. So let's say this is point number 2. So we've got x2, y2. We've got x1 and y1 on point number 1. So y2 minus y1, that would be 2 minus 2 on the top. And on the bottom, we've got x2 minus x1. That's a negative 1 minus 5. Okay. 2 minus 2 is 0. Negative 1 minus 5 is negative 6. So my change in y was 0. The line doesn't go up or down. There is no change in y, where the change in y is 0. The change in x would be negative 6. So that's how far that changes. 0 divided by negative 6 is just 0. So the slope of this line is 0. So if you have a flat horizontal line, its slope is 0. All right, let's look at another interesting example. So what's the slope of this vertical line? Okay, so I've got 2 points. I graphed the 2 points, drew the line through it. This time the line is vertical. So as you're going from left to right, does this go uphill or downhill? Well, there really is no left to right. You can't walk left to right on this line. It always stays in the same vertical position. So let's see if we can figure out what its slope is. Okay, so the same thing, we use the definition of slope, changing y or changing x. To get the change in y, we do y2 minus y1. To get the change in x, we do x2 minus x1. All right, so let's call this x2, y2. Let's call this x1, y1. So to find the slope, I do 5 minus 2. And I do 3 minus 3. 5 minus 2 is 3. 3 minus 3 is 0. And notice we have a 0 in the denominator. That's bad. You can never have a 0 in the denominator of a fraction. So this is undefined. No zeros in the denominator of fractions. So a vertical line has an undefined slope. All right, another really important concept we'll be talking about this year is acceleration. So we learned about velocity a few minutes ago. Now we're going to talk about acceleration. Acceleration is the change in velocity over the change in time. So acceleration is how much your velocity changes. How much your velocity increases or how much it decreases. How much you slow down or how much you speed up. All right, so let's say that we have a constant acceleration here. So the acceleration is always going to be the same number. Let's say that 2 seconds after the stopwatch was started, this person's velocity was 55 miles an hour. So let's say that after 5 seconds, their velocity was 70 miles an hour. So we want to know how fast their velocity was changing. And we're saying that it's always constant. Acceleration is always constant. So every second, the velocity will go up the same amount. So if the velocity was 55 miles an hour at 2 seconds, another second later, the velocity is going to increase by the same amount as it does the next second, or the next second. So we'll get this straight line. So if acceleration is the change in velocity over the change in time, to get the change in velocity, we need to subtract the 2 velocities. To get the change in time, we need to subtract the 2 times. So notice all we're really doing here is finding the slope. All right, so velocity 2 minus velocity 1. Let's say that the bottom one is number 2 and the top one up here is number 1. So that'll be 70 minus 55. Always keep your units in word problems. So this is miles per hour divided by the change in time. I'm going to do T2 minus T1, so that's 5 minus 2. And that's seconds. All right, we simplify this. 70 minus 55 is 15 miles per hour. And 5 minus 2 is 3 seconds. All right, 15 divided by 3 would be 5. And then our units are miles per hour per second. Okay, so what this means is that every second the velocity was increasing by 5 miles an hour. So let's look at our graph here. So at 2 seconds I was at 55. So at 3 seconds I should go up 15 and I will be at, after 1 second I'll go up 5 miles per hour. Let me try this again. So our velocity increases 5 miles per hour every second. So if at 2 seconds I'm at 55, at 3 seconds I'll be at 60 miles an hour. At 4 seconds I'll be at 65 miles an hour. At 5 seconds I'll be at 70 miles an hour. All right, so I've given you some practice problems here. On this first one, I want you to match each one of these 4 graphs with these 4 statements down here. Then answer this question on number 2, this question on number 3. Represent those graphically, so graph it and then algebraically answer the questions. So pause the video, and once you work out all the problems, restart the video, And I'll go over each one so you can check and see if you got the right answer. Okay, so the first one, let's see. This one, as I go from left to right, is going uphill. So it's increasing from left to right, so that would be the positive slope. This one is going downhill from left to right. It's decreasing downward. So this would be negative slope. And the horizontal line we said had a slope of 0. So the y value doesn't change. The change in y is 0. So this has a 0 slope. And here, the x value doesn't change. So the denominator of the fractional slope would be 0. So this one is undefined. So vertical line has an undefined slope, horizontal line has a 0 slope. Okay, find the slope of the line that goes through those 2 points. Let's graph those 2 points. So I've got 2, negative 7, and I've got negative 3, 8. And we got a line that goes through those. All right, so the first question to ask, will my slope be positive or negative? It's going to be negative, so make sure the answer is negative. So slope is the change in y over the change in x. So my change in y would be 8 minus negative 7 over change in x, that would be negative 3 minus 2. So 8 minus negative 7 over negative 3 minus 2. 8 minus negative 7 is 15. Negative 3 minus 2 is negative 5. So my slope would be negative 3. Okay, it's negative and it's negative. All right, here we got a word problem. Always make sure you keep units in your word problems. So after 5 months, Jack had $300 in the bank account. After 7 months, he had $180. So we're going to put the months on the horizontal axis, the dollars on the vertical axis. All right, so let's graph that. So after 5 months, he had $300. After 7 months, he had $180. Okay. The growth rate of his account was constant. Okay, so he was always, in this case, losing the same amount of money every month. So if we graph that and make a straight line, what was the growth rate? So we're going to want to know the change in dollars divided by the change in time. Okay, to get the change in dollars, we will do 300 minus 180. That's dollars. And to get the change in time, see, the 5 goes with the 300. I'm going to label these so don't get confused. And that's 780. So if I did 300 minus 180, I had to do 5 minus 7. And that's months. 300 minus 180 is $120. That is right, yeah. And 5 minus 7 is negative 2 months. So I get 120 divided by 2 is 60. So I get negative $60 per month. Okay, it's negative because he's losing money. The graph is going downhill, it's decreasing. So he's losing $60 every month.